So now let's go ahead and continue where we left off with our discussion on how we can optimize these objective functions at given points here. So here we have our objective function is z equals x plus 3y. Our constraints are x plus y is greater than or equal to 2, x is less than or equal to 6, y is less than or equal to 5, x is greater than or equal to 0, y is greater than or equal to 0. Now, I should mention that these constraints are always implied. Our axes are going to be our ways of kind of restricting where we are going to be looking. So even if those aren't listed, you should always be noting that you will be checking relative to your axes here. So these should always be in your constraints, even if they aren't necessarily listed directly. So let's take a look here. I'm just going to go ahead and start graphing these. X plus y is greater than, and then put your equal sign there, 2. X is less than or equal to 6. Y is less than or equal to 5. X is greater than or equal to 0. Y is greater than or equal to 0. Okay. So we need to see where all of these regions are true. So it needs to be here, 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 here. Okay. So if we take a look here, we'll just take a look at where they intersect. So here, 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 and here. Now, if you're thinking that we should go over and get these, remember that we have the constraint x has to be greater than or equal to 0, so anything to the left of this is not going to stay in this blue region here, okay? So just to confirm, we start here, because this is where they all intersect. They intersect here. They intersect here, here, and here, okay? So these are going to be the points that I am going to test. So let's take a look. We have 0, 5, 0, 2, 2, 0, 6, 0, 6, 5. These are the points we're going to test. So let's plug this in. Z equals x plus 3 times y. Z equals 0 plus 15. That gives me 15. Z equals 0 plus 3 times 2. It's going to give me 6. Z equals 2 plus 3 times 0. It's going to give me 2. Z equals 6 plus 3 times 0. This is going to give me 0. So this is going to give me a total of 6. Z equals 6 plus 3 times 5. 6 plus 15. That's going to give me 21. Okay. So based on what we see here, what do we believe our maximum is? Our maximum is z equals 21, and it is attained at 6, 5. Okay? So, graph your constraints, then plug in your objective function for each of those. Now, I mentioned we're going to take a look and see what happens when we have we're just given information and we're asked to find what our objective functions are. So let's go ahead and take a look at that. If you want to see or take a look more at these examples, please pause the video now as it's about to disappear. So let's take a look here. You are about to take a test that contains computation problems worth 6 points each and word problems worth 10 points each. You can do a computation problem in 2 minutes and a word problem in 4 minutes. You have 40 minutes to take the test. You may answer no more than 12 problems. Assuming you answer all the problems attempted correctly, how many of each type of problem must you answer to maximize your score? And what is the maximum score? Okay. So here, first, we need to find out a few things. So since this is an optimization problem given particular constraints, this is a linear programming problem. So we need to figure out first, what is our objective function? So our objective function z equals. Now we need to figure out how many of each type. So we have word problems and computation problems. So I'm going to say the computation problems here, these are x. I'm going to say the word problems, these are y. Okay. So since it's worth 6 points for a computation problem, it's 6x is the number of points I'll get for each computation problem. Okay, because there's 6 points for each one. So if I do x computation problems, it's going to be 6x total points there. Now what about for y? So I'm given 10 points for that. So what do you believe that this is going to be? Plus 10y. Okay, so make sure that we have that down first. So we want to maximize our number of points. So we need a formula for our points. The formula for points is 6x plus 10y. Okay, so that's our objective function. So now we need to figure out what our constraints are. Okay, so let's see here. You can do a computation problem in 2 minutes and a word problem in 4 minutes. I have 40 minutes to take the test. So what does that do for us? Well, that means that 2x plus 4y, so this is the number of minutes that I spend on computation problems, the number of minutes I spend on word problems, that has to be less than or equal to 40. Okay, so this was just my constraint of the 40 minutes here. Okay, now I may answer no more than 12 problems. That means the number of computation problems plus the number of word problems has to be less than or equal to 12. Okay. Assuming you answer all the problems attempted correctly, how many of each type? Now note here, it's not listed under these constraints, but there is an implied x is greater than or equal to 0, y is greater than or equal to 0. Now, it doesn't seem like there are any other constraints. We've dealt with this 40-minute constraint. We've dealt with the 12-problem constraints. So now, these are the constraints. Okay. So if you didn't see how we got those constraints or the objective function, go back and double check. If you're still struggling as you go through it and you can't quite see how we got that, please do let me know. Email me. We can do some virtual office hours in order to clear that up, or I can record another video here. Okay. So now we have these constraints, so we need to figure out what points we're testing now. So your first step, find your objective function. Your second step, find your constraints. Third step, graph your constraints. 2x plus 4y is less than or equal to 40. X plus y is less than or equal to 12. X is greater than or equal to 0. Y is greater than or equal to 0. Okay. There we go. So now, I'm just going to go ahead and move this over to make sure that we can get all of our area here. So now we'll check. What are the points? 0, 10 is a point. 0, 0 is a point. 12, 0 is our point, and our last one is where they intersect here. Okay. So we're just checking to see where do our regions intersect and allow us to be in all the regions here. Okay. So my points that I'm going to test are 0, 10, 4, 8, 0, 0, and 12, 0. Okay. So 0, 10. I'm going to plug this in here. Z equals 6 times 0 plus 10y. Oh, and y is, of course, 10. 6 times 0 is 0. 10 times 0 is 100. So I get 100 points if I just do the 10 word problems. Now what about here? Z equals 6 times 4 plus 10 times my y here is 8. 6 times 4 is 24. 10 times 8 is 80. Add these up and I get 104. Then here, 6 times 0 plus 10 times 0. 0 plus 0 is 0. So if we don't do any problems, we don't get any points. Riveting stuff. Then over here we have z equals 6 times x is 12 plus 10 times y is 0. 6 times 12 is 72. 10 times 0 is 0, so z equals 72. So, based on the information, which one should we do? We should do this one here. So if we do 4 computation and 8 word problems, that is the number of each type. And what is your maximum possible score? The max possible is 104. And there we go. Okay. So, what did we do here? So, let's get a step-by-step guide to figure out how we handle these. So 1, find your objective function. Now your objective function is what you're trying to maximize. So your goal is to figure out how can I find a way to maximize this objective function. The second one, now that we have our objective function, we need to find our constraints. Remember that an implied constraint or constraints are these. These are always implied, even if they're not stated. Then here, our third one, after we have our constraints, we will then graph our constraints. After we graph our constraints, we then find the vertices. That is to say, we're going to find our points where they intersect, as we have found over here. Okay. Then after we find the vertices, we then evaluate our objective function. At the vertices. Okay. And those will be what you're going to use to determine what you're going to do here. Okay. So you'll note, baked into this, there's a lot of graphing of inequalities and whatnot. So I am more or less expecting you to be making use of Desmos on your homework problems. Now, if you're wondering what I'm going to do for an exam, if I decide to have you do a paper exam, well, what you'll do for that is I will provide you with these vertices. So I would expect you to do steps 1, 2, and 5. I would not expect you to do 3 or 4 without graphing software, because you'll note you need a very high level of precision on these ones. So don't worry about those. Those are not going to be ones that I expect of you. Rather, I'm going to be providing those for you on an exam. But for the homework, I will expect you to do this. If you're looking at what do I do for this, then just go ahead and take a screenshot or take a photo on your phone, and then that'll be good enough. Okay. Let me know if you have any questions on this section or you want to see any more examples here. Otherwise, I will see you in the next video.